Right, so it's time to talk about the types of stationary points as we did on Friday, but just to reiterate a couple of points there. So here we've got a curve. It's probably a cubic actually because it's got 1, 2, 3 turning points. Sorry, a quartic. But what we've got just a few different types of points, and we need to just discuss what they're called and that sort of thing. So as we move from left to right, we've got an increasing curve with a positive gradient. We dip through this point A, which is a stationary point. Right, we've discussed that. We're talking about now what type of stationary point it is. Well, it's obvious that by looking at that we've got a local maximum. All right, so we need to call it that as a local maximum. All right, we discussed, didn't we, about why it's called a local maximum, not an absolute maximum, because it's not the maximum value of the curve. It's just the maximum in its locality, which means it goes from a positive to a negative gradient. And then B here is a local minimum, and its feature is from left to right. It goes from negative to positive. Now C is what's called a point of inflection. It doesn't point. How do they spell inflection with an X? It varies. I'll stick with the textbook. Inflection. It's a point of inflection. Point of inflection is one where concavity changes. So this is concave down here, and this is concave up. So there's a point of inflection in here somewhere, where it changes from concave down to concave up. Now, so that's a point of inflection is defined as a change in concavity. So concave down to concave up. See how it goes? Smiley face. Now here it's concave up, but it's turning to concave down right here. So it turns to concave down. So that's a point of inflection. So it goes up. Now so concave up. Now it's going to become concave down. So this is in a concave down bit. So the point of inflection is, in this case, it's called a horizontal point of inflection, or a stationary point of inflection. So its feature is that its gradient doesn't change either side of it. So as we looked at, the test for what type of stationary point we've got is to look either side of the stationary point and see what's happening to the gradient at the points either side. If it's going from plus to minus, you've got a little max. If it goes from minus to plus, you've got a little min, local min. If it goes from plus plus, or in fact if it's going from minus to minus, you've got a point of inflection. These are also called turning points, A and B points. So you could call these turning points as well. We might just make a note of that. Turning points there and there. Okay, so how do we test? Well, we just talked about how we test. Let's just maybe get straight into an example. Okay, so we're just going to look at this example here. For the function y equals x to the power of 4 minus 4x cubed, find all stationary points and state their nature. Then we're going to sketch the graph. Okay, so we're after stationary points. That's a trigger for us to find the gradient function here. So we'll do that. dy dx equals, what happens here, 4x cubed minus 12x squared. Okay, so that's gradient function. For stationary points, we make that equal to 0. All right, make the point there. That's for stationary points, because we know that at stationary points, our derivative function is equal to 0. So now we're going to solve this. So therefore, I'll take out a 4x squared, can't I? X minus 3 is equal to 0. So therefore, x equals 0 or 3. So I've got stationary points at 0 and 3. Okay, when x is 0, we're going to put y equals back into the original function, remember, to find the y coordinate at x equals 0. That's going to be 0. And when x is 3 to the power of 4, that's 81, minus 4 by 3 cubed. 3 cubed is 27. 4 by 27 is 108. So I've got 81 minus 108. That looks to me like minus 27. So we put that in. So we've got our stationary points now, so I can therefore say my stationary points are at 0, 0 and 3 minus 27. Okay, so we found the stationary points, state their nature. Okay, so now we need to find out at 0 and at 3 what's going on. So let's go to test our signs either side of 0. So firstly, what we do is we have a look at, okay, we look at -1, 0, and 1. Okay, so we check the sign at each of those points. So at 0, I know the sign, my value of my gradient, so I'm subbing these in now. So these are my values of x, and what I want are my f-x values. So at f-x, I know, right, here's my f-x here, 4x cubed minus 12x squared, 0, 0. At -1, what have I got? I've got -1, that's probably easier in here, -1 squared is 1, times 4 is 4, times -1, so this is positive, times, so that looks like it's a negative. Put 1 in here, that also looks like it's a negative. So it looks like at 0, 0, look at that, we're going from negative, which is like this, to 0 to that. What does that look like? Looks like one of those points of inflection, doesn't it? So that looks like what we've got there at 0, 0. So we've got a point of inflection, that horizontal point of inflection. So now at 327, so this was at 0, 0. Now we're going to look at 3 minus 27. So my values of x are going to go from, with 3 in the middle, so I'll go 2, 3, 4, I imagine, and then go and test my gradient values at those points. I know that at 3, I've got 0. At 2, what happens? 2 squared is 4. 4 is so this is positive. 2 minus 3 is negative, so this will be negative. And at 4, I'm going to have a positive value, aren't I? So it's going from negative to positive. So I've got this is a point of inflection. This will be a local min at 3 minus 27. And so now we go to graph it, put all that information together. We've got all the info now, so we put it into a graph. So we step up to put in 0, 0, 0, 0. I've got something like this happening at 0, 0, and then at 3 minus 27. Remember, this is just a sketch, so don't get too hung up on scale. At 3 minus 27, I've got a min. So I reckon what's going on here is, I could extend this down here, so at least I've got that covered. I reckon what we got here is a curve that comes down like this, goes through a horizontal point of inflection there, comes down, dips through at 3 minus 27, back up, and goes on endlessly in that direction. Okay, so I reckon that's going to be our curve that reflects the information we're given there. Okay, that's enough for this screencast. Let's do some work from exercise 20D on the next lesson. I see you. Cheers.